Hello and welcome to Reviewing and Deciphering Application Insights Telemetry, a part of the Monitoring and Troubleshooting Applications with Application Insights course. In this module, we will simulate real-world load on a web application monitored by Application Insights and walk you through how to pull the information you need to bulletproof your applications. My name is Kevin Griffin. I'm an independent software consultant and 10-time Microsoft MVP, focused in ASP.NET development and deploying solutions to Microsoft Azure. It is my pleasure to teach you some of the ins and outs of Application Insights and how it can be beneficial to your projects. In this module, we are going to walk through the basics of reviewing data collected by Application Insights. First, we'll look at the types of metrics collected by Application Insights and how you can see how your application is performing. Then we'll go deeper into the metrics and show you how to diagnose an error and how to diagnose potential performance issues. In this section, we'll discuss how to review and decipher metrics collected by Application Insights. When you log into Application Insights, you're presented with an initial dashboard that shows you 4 metrics: failed request, server request, request response times, and application availability. Now, Application Insights isn't designed to be a portal you spend a lot of time in on a daily basis. It's more likely you'll log into the portal once every morning or afternoon and look at how the application is performing over the past 6 hours or past 24 hours. And even then, you're looking for anomalies in the data. A great example is the screenshot on the right. The server request chart is showing average number of requests being around 2,000 or 3,000, but then there is a massive spike of 20,000. This might be a symptom of a bigger issue that we'll want to investigate. Let's walk through each metric independently and discuss what to look for. The failed request chart will show you the number of requests coming into your server that end unsuccessfully. In terms of web applications, these are going to be requests that return a 400 or 500 status code. The failed request chart will show you the number of requests coming into your server that end unsuccessfully. In terms of web applications, these are going to be requests that return a 400 or a 500 status code. It is common to be a little freaked out when you see a blip on this chart, but one of the most common types of errors we see in our applications are 404 not found responses. Clicking on this chart will take you deeper into the failure search and analytics tool. Next is the server response time graph, and this will give you an overall picture of how long it is taking your application to respond to a request on average. Obviously, the higher the average response time is for your application, the longer people are waiting for actions to happen. An optimization goal should be to get the average response time down to a manageable level. This depends on your application and your team, but our teams tend to strive for a response time under 1 second. The screenshot on the right indicates a problem in our applications. A massively high average response time is followed by a period of no data, as indicated by the dashed lines. You would need to correlate this with other aspects, but the most likely case is the application crashed due to server stress and was unable to recover. The server request graph will show you the number of requests per minute your application is handling. This view will not tell you if the requests have been success or error responses, only that a request was handled by the server. As a side note, in order for a request to be counted by Application Insights, it needs to actually be handled by your application. There are cases where your web server, like IIS, might handle the request before it even enters your application. These are server errors and not actually a metric reported by your web application. While not covered in depth in this module, if you have application availability tests enabled within Application Insights, the average results will be displayed on the overview dashboard. By default, availability tests will check the access to your application from a variety of Azure data centers around the world. Your goal should be to have 100% availability in all data centers tested. Again, dotted lines indicate no data is available. While it might not be a view you spend a lot of time with, The application map can provide at-a-glance insight into the relationship of your application with a variety of services and dependency it interacts with. For each of these dependencies, you're provided with at-a-glance counts of how many calls are made to the service and its dependencies, what the average amount of time is for each call made to the service, and also what percentage of errors made to the services resulted in errors. The overview page of Application Insights provides 60 minutes of data by default, but this is easily adjustable by using the timescale bar at the top of the overview page. It is common in our projects to scale down to 30 minutes when we've recently pushed out a new deployment to our application, and we want to get an idea of how metrics adjust, if at all, to the new deployment. Likewise, after a deployment has been live for a couple hours or a couple days, we'll extend the timescale to days in order to get a better picture of the before versus the after. It's also worth noting the 60 minutes default is only on the overview page. Drill down views often default to 24 hours, but can be adjusted similarly. The overview page is useful for quickly checking in on your metrics to see if there are issues you should be concerned with. However, what about when you are concerned and need to see what's happening right now in your application? The live metric stream provides you with real-time sampling of what is happening across all servers, services, and dependencies in your environment. The live metric stream shows you all the overview metrics such as request rate, duration, and failure rate. It also shows dependency call rates, durations, and failures. Towards the bottom of the screen, Live Metric Stream will also show you memory and CPU utilization across the servers your applications are hosted on. These metrics are even broken down by server at the very bottom of the screen. And finally, the right sidebar provides sample telemetry when trace events or exceptions occur. And the screenshots are lovely to look at, but let's explore Live Metric Stream in action with a website under load. For this demonstration, I've already taken the time to set up an application on Azure App Services. I've connected it to an instance of Application Insights. As you can see, I already have some data that's been logged against this site because I've been running some stress tests. For this example, I want to talk about live metrics. So if I go to the live metrics section of the Application Insights sidebar, you'll see I'll load up this really cool looking dashboard, and it's not doing much of anything right now. All my different charts and graphs are showing zeros. I have a little bit of memory that's currently in use, and the CPU is kind of ticking up and down. But for the most part, this server is not handling any requests at the moment. Now, real fast, I just want to tell you the tool I'm using for load testing and stress testing against my application. And that's a tool called Siege. This is a Linux-based tool that will just attack your web server with whatever endpoints you want it to hit. If you'd like to learn more about Siege, I'll put a URL below. A little bit of information about the commands that I'm using. I am going to make a series of attacks against my web server, and I'm specifically pointing out different URLs with the server.txt file. And I'm telling Siege to use 50 clients to simulate internet-based traffic against those URLs. So a good example is I have a couple API endpoints, one that hits a database, one that hits a delayed response, and one that sometimes throw an exception depending on what the random number equals. And then there are normal just home, privacy, standard things that are built into an ASP.NET Core default template. Siege is going to just attack our server over and over and over again. It's not going to stop until I tell it to stop, which makes it the perfect utility for testing out application insights. So if I hit enter, the attack on our server will begin, and we can switch back over and see what's happening. We can see the data starting to come in. And I'm just going to let the tool run indefinitely, and we'll walk through the different sections of Live Metric Stream. First, we'll start at the top bar. We have our request rate and our request duration. So this is telling me on average how many requests is my server handling at any one particular moment. As you can see, it spiked up real high because all the initial requests started coming in, but then it kind of valleyed, and it's going in a routine. And this is normal. Depending on the day-to-day usage of your application, this will peak and valley at different levels. Next, we have request duration. And this is telling you on average how long a particular request is taken to respond. As you can see, we have some that are really fast that are just a couple milliseconds, but then others are taking closer to 2 seconds to return. And just in time, we just had our first spike on the request failure rate. And this is a chart that tells you on average how many errors are occurring inside your web application. As you can see, I got one and then another. And this is really interesting because you can correlate it with a sample telemetry over in the right sidebar. And this is going to tell you what exception got thrown, when it got thrown, and also give you a call stack for where the application error occurred. And you can use this to go back to your application code and fix the error. Normally when requests error out, you'll get 2 messages inside a sample telemetry. One is going to be the actual exception itself, and next is going to be a 500 internal server response. If we move down to the next line, we have our outgoing requests, and these are going to be any requests where something hits our server and then we need to go out to an external dependency. This is going to be SQL Server, whether it's Azure SQL Server or it's your own internal SQL Server database. This is going to be any web services that you need to talk to. Anything that's outside of your web application will register on this graph. And you can see we have a database facing call that's calling to our database anywhere between 0 to 10 times per second. Well, what's even more interesting is for each of these calls, how long are they taking to respond? Now, the database call that I'm making is pretty straightforward. It's a simple select statement, but they're returning in less than 10 seconds on average. This is a good number to see. If this dependency call graph goes up into the seconds, that might be something to worry about. And not all dependencies return successful every single time. So there's a dependency call failure rate graph as well. If any of our SQL calls or our web service calls were to throw an error or not return successfully, it would show a blip on the screen. And down here at the bottom, we have our overall health of our web application. And this is going to show you the committed memory in the CPU for all the servers that are currently running your application. And you'll see down here at the bottom, there's a list of the servers currently reporting to Application Insights. Now I'm going to show you a really cool example where we can show multiple servers all running inside of Live Metrics. I've switched back over to my app service, but if I go to scale out on my web application, I can increase the number of instances of my web service that are running on top of this machine. So I'm going to bump it up to 3 and hit save. And within a couple seconds, you can see I now have more servers that are monitoring for requests against my web service. And there you go. That's Application Insights Live Metric Stream, which is a great dashboard for if you just need to see what's happening at the current time without going through all the different logs and charts and graphs and waiting for data to get computed. In this section, we're going to dive deeper into the failure and performance sections of Application Insights so you can drill down to the exact issues your applications are seeing. As recently discussed, the overview dashboard will provide you with at-a-glance metrics for what is happening in your application. Metrics, such as failure rates and response times, will allow you to drill down into the numbers by forwarding you to the failures and performance subsections of Application Insights. These metrics are also available via the failure and performance links in the Application Insights sidebar. The Failures tab is the ideal place to turn to if you're experiencing errors or exceptions in your applications, whether it's on the server side or the client side if your application is web-based. In this view, you'll see an itemized list of endpoints and total number of issues experienced during the time frame. You can drill down into any one endpoint to see the top response codes or exception types. And if endpoints are failing due to dependencies, you can see which dependencies are failing as well. Let's take a couple minutes to explore an application that is failing within Application Insights. In this demo, we will walk through the failure section of Application Insights and seek out some of the common issues happening in our application. Jumping back into our sample application, you can see I have a lot of traffic that's hitting this website at any particular moment. Our server requests are showing somewhere between 4,000 and 4,500 different requests per minute. And that's a lot going on. Then looking over at our failed requests, you can see we're getting somewhere between 2 to 6 per minute, depending on what's happening. And this might be a common scenario in your application. While you want to have no failed requests, it's very unlikely. Any little thing that happens in your application, whether it's a 404 not found or a 500 something internally went wrong, it's going to show up in your failed request graph. So don't freak out too much when you see a little blip every now and then. But as you can see here, I have a lot of blips over a period of time. And that's telling me that something is wrong inside my application. I want to dive in and take a look. So how do I do that? Well, there's two ways to get to the failures section of Application Insights. The first is you could just click on the graph and it will take you there. The second is you can go to the failure section of the sidebar. They both go to the same location and they both give you the same information. So this is the failures dashboard, and this is going to tell you how much stuff is going wrong in your application over a period of time. Now let's explore the couple different sections here. While your applications might have a lot more information, my demo app is just showing one endpoint with a failure. And let's dive in a little bit more, see if we can figure out what that issue might be. So first, you're going to automatically go to the graph. You're going to see, well, we have 21,000 requests coming in and about 19 different errors coming in. So the percentage-wise of number of requests to failures is not terribly high. So it might not even be a big deal. And we can go down to the bottom of this screen and see exactly which endpoints are causing issues in our application. An important thing to note here is that this entire dashboard is going to be limited by what your current date range is. While the front dashboard, the overview that we were just on, is automatically limited to the past hour, this one is going to be limited to the past 24 hours. So one of the things I like to do when I'm in this view is I will go back and forth between the last 30 minutes if I want to see just what's been happening recently, and also anything within the past 3 to 7 days. Because sometimes there are issues that only pop up at really inconvenient times, like 2 o'clock in the morning or right one time at noon, and you don't know when that's going to be. So adjusting your date range or your hour range to see the exceptions that are occurring at the times where you might not be in front of Application Insights, that's going to be a really useful thing to look out for. And once you know the operation that you're looking at, you can see, well, I have 1.34 thousand failed requests out of the 283,000 requests that came into the server. And you can click on that and get a more detailed view of the request counts versus the failures. Now, this is going to be scoped to all the failures and all the requests that you have coming in. So you can see that, let's just look at the peak. Even though I had hundreds of thousands of requests coming into the server, At this particular time, 67,000 of those were going to the stress/delay endpoint. Well, of those, 251 of them ended in a failure. So 67,000 of them were just fine. 251 of them had an issue. All right, well, what was the issue? That's where we head over to the right sidebar. And this is going to give you top 3 response codes and exception types and failed dependencies if those are an issue. You're not going to get all the information about it. So if you have a lot of different issues with this particular endpoint, you're going to have to drill down into the operations yourself. But 99.9% of the time, you're going to get all the information you need from the top 3 response codes and, more importantly, the top 3 exception types. Well, let's dive into each one independently. Top 3 response codes are going to tell you what commonly happens when this request is made and a failure returns. Sometimes that might be a 404, sometimes it may be a 401, sometimes it might be a 500, or any combination of response codes could occur. And clicking on the count will give you a more detailed sampling. So these are all the different requests that were coming in, and they returned 500s. And clicking on them will go into what's called the end-to-end transaction details. Now this view is really interesting, and it gets more complex as your code gets complex. My demo application is pretty simple. We hit the endpoint and it throws an exception. There's nothing in between. So let's click on the exception and see what happens. Well, Application Insights is always monitoring for different exceptions that occur in your app. So we found out here that this particular exception occurred at a certain time. The message that returned was random number was greater than 9,900. In another module, we talk about custom properties and custom metadata. If you were to pass any of that along to your exception tracking, it would appear here in custom properties. And if it might be useful to you, you can go down even further and see the call stack for this entire method call. And most of this is going to be internal Microsoft stuff, ASP.NET Core, whatnot. You can click this handy button, Just My Code, and it'll tell you, hey, your issue was in the stress controller on line 53. And if we were to go to that code right now, we would see where I'm throwing the exception, and we could backtrack from that issue. Little thing to note here is if you're tied into any issue tracking with Azure DevOps or GitHub, you can create a work item automatically that takes all this information, puts it into an issue, so you can come back and do the research on it later. Well, let's go back to the overview here and see top 3 exception types. As you can see, my top exception is just exception, but sometimes this might be other exception types, such as a not found exception or a SQL exception, or you name it. Specialized exception types will appear here the way that you expect to see them. And clicking on the counts does the exact same thing as before, except this time it tells you exactly what the exception is. Random number was greater than 9,900. And you can click into these exceptions and get more detailed information from each individual sample. Exploring this view a little bit more, we can go into a dependencies error section. And if we were to have an exception such as a SQL Server dependency issue, those exceptions would show up here because it's an exception or a failure that occurred while talking to an external dependency. The exceptions tab gives you the same data, just viewed a little bit differently. And in this particular case, it's not going to show you issues based off the endpoint. It's going to show you issues based off of where the issue occurred. So my one exception that was thrown a couple dozen times is occurring in the stress controller. So I can go in and see, well, what's happening in this particular method in my application. And we can see, well, there's 1.37 thousand exceptions that occurred of type of exception. And all these still go into the sampling. By default, Application Insights is collecting 100% of samples sent to it. So this list is all the issues that occur. and we can drill down into each individual one if we want to. Application Insights does a really good job of just filtering the one that's worth your time to the top, so you don't have to go through all these individually. And the last tab is the roles tab. So if you have multiple applications that are all reporting to Application Insights, in my case, I have 3 web services that are all responding. I can take a look to see if one server is having an issue over another server. And depending on how you have your load balancer set up, you might have more traffic going to one server than another server. But in my case, things are pretty well distributed compared to the number of requests coming in and the number of failed responses. So my issues most likely are not with a particular server. It's probably something inside of my code. There are likely cases where you have one server that is erroring out at a higher rate than your other servers are. Maybe a restart or a reconfiguration of that machine would fix all your issues. Another major thing to note here as well is we have a toggle up in the top right hand corner for server and browser. If you are taking advantage of the browser side tracking of Application Insights, meaning your application is served up by a server that is hosting Application Insights on the server side, but it can also track issues that happen on the client side. So if something is in the web browser and an issue goes wrong, that gets reported back to Application Insights. Clicking on the browser tab will show you, well, there's nothing really happening in the browser. Everything's empty, nothing's occurring. But sometimes you might have JavaScript that goes wrong. When those JavaScript exceptions occur, they show up here as a dependency error. And you can drill down into the JavaScript to figure out what the issue might be. The Performance tab is the ideal place to turn to if you're experiencing performance issues in your app, whether it's on the server or the client side if your application is client-based. In this view, you'll see an itemized list of endpoints and the average duration of the operations during the time frame. You can drill down into any endpoint to see the scale of durations. Additionally, you can dive into the performance of your dependencies to see how well they're performing. So let's take a couple minutes to explore the performance of an application in Application Insights. In this demo, we will walk through the performance section of Application Insights and seek out some of the more common issues happening in our application. Server performance is definitely a rabbit hole that you can tumble down and spend a lot of time in. And what I like to do is show you just some of the bits and pieces that will get you started in dissecting some performance issues if you think they're occurring. And like all good demos, they start at the Application Insights overview screen. And the 2 metrics we're really interested in looking at are server response time and server requests. So we looked at this before. There's a good amount of traffic going to this web server at any one time. And looking at our server response times, we can see the response times are really good. Anything under a second, in my opinion, is a great response time. Now, ideally, you want to get that number as low as possible, but overall, anything under 800 milliseconds is fantastic. Well, let's dive in a little bit deeper and go into the performance section of Application Insights. The 2 ways we can do that, first is clicking on the server response time graph or clicking on the performance item on the sidebar. Now, this view might look very familiar if you watched the earlier demo on the failure section of Application Insights, because it really is. It's the same view with most of the same details. Now, let's explore what exactly we're looking at. First, your eye is going to go to the graph, and this graph is going to show you the request counts versus the response times for the last 24 hours of your application. Now, like other views in Application Insights, you can filter this view to any time period that you want. I typically go back and forth between the last 24 hours, the last 30 minutes, and sometimes the last 4 to 6 hours. It really depends on what I'm looking at. Most cases, I want to see if an issue with a deployment has fixed or worsened a performance issue with an endpoint that I was working with. The bottom part of the screen are the various operations that are occurring in your application and how long they're taking to respond. Now, this is automatically going to be ordered by the longest running endpoint. As you can see, I have a call called stress delay. And what this is doing in my demo app is every time it's called, it will wait a random amount of time between 1 second and 10 seconds, and then it returns. Our average duration for this call is about 5 seconds, which isn't horrible, but it's not the best that we could possibly get as well. And we have other calls in here, such as get database result, which actually goes to another dependency, gets some data back, and then finally returns. You can see the calls to our JavaScript and CSS assets on our application. Those are all things that get delivered by our website, and they're things that we might want to factor into some of our performance optimization. For example, our jQuery and our Bootstrap JS files are taking about 5 milliseconds to return. That could be better because they're static resources. This demo application doesn't have any optimizations turned on, so there's a place that we might be able to go improve. Well, let's click on delay and see what type of information we can get out of it. Well, really not too much because we're not talking to any external dependencies. It's just a slow method. The graph on the right side will show you the distribution of durations over a period of time. And this really shows you that the majority of my response times come in at under 5 seconds. And it's really the 50th to 99th percentile that are above that 5-second number. Let's check out another result, the get database result. And this talks to an external dependency. You see we have a distribution of durations again. Not too bad because everything returns in under 35 milliseconds, which is fantastic. Now this talks to a database, and databases come with their own performance aspects that we might want to look at. And we can look at this information by clicking on the top 3 dependencies for this particular call. My application only talks to SQL Server, but it could also talk to blob storage or table storage. It could talk to external web services. Any dependency would show up in this list depending on the endpoint that you're talking to. Now, because this call always talks to SQL Server, we can dive in a little bit deeper into these particular calls. So I'll go into the suggested transaction, and this view again should look familiar. You have a request that comes in, a little bit of data about it, took 15 milliseconds to respond, responded with a 200 OK. But in the transaction timeline, it talked to a database. If we look at that request, it took 2 milliseconds to go to the SQL Server, make the request, get the data, and return the request. But not just that. Application Insights is smart about SQL, and it's going to tell us what the command was that got run against the SQL Server. And I can use that for optimization. If this was a slow call, I could take that information, go optimize my query, add some indexes, do some general stuff that database administrators do, and then later come back to these sort of transactions and see if there's been any improvement. Similar to the error section, if I want to take this performance information and turn it into a work item in Azure DevOps or GitHub, I can click the Create Work Item button. And if we go back to the overview and go to dependencies, this will show you all the dependencies of your application and their performance metrics. For my application, there's only one SQL Server connection that's occurring, and it's returning pretty efficiently. And again, like all these requests, I can dive into the samples, and the samples are going to be everything that's come into my server. We can limit the sampling to not just 100%, but maybe 50% of the samples or 33% of the samples. And with any of these samples, you can click on one or the suggested one and go back to the transaction details and learn a little bit more about what's happening underneath the scenes. And similar to the failures tab, we can go look and see how the communication is distributed against all the different roles and instances that are talking to application insights. This application has 3 web servers talking to it. And at this rate, the average dependency duration is within a millisecond of each instance. Not a big deal, nothing to worry about. If you have browser analytics enabled, so not just on the server, but on the browser as well, you can go to the browser tab and see how well are the various pages you're rendering performing. Now let's take a look here. I have 2 endpoints on this application. There's the main homepage, and then there's a privacy page. Well, the main homepage takes about 2 seconds on average to load, and then the privacy page takes a little under 1 second to load. In summary, we discussed the Application Insights Overview Dashboard. It is useful for seeing how our application is performing at a glance by showing you request rates, failure rates, response times, and application availability. Need metrics in real time? No problem. The live metrics stream has you covered. All relevant performance and request metrics are streamed to you in real time, including telemetry for custom events and errors. Finally, this information is useful, but you can drill down further by using the failures or performance sections for more detailed metrics. Learn exactly what your application is doing and take steps to improve it. Thanks for listening to the Reviewing and Deciphering Application Insights Telemetry module, part of Monitoring and Troubleshooting Applications with Application Insights course on Skill Me Up. My name is Kevin Griffin.